We will create a UT phased array configuration for the following specimen. It is a 44 millimeter thick plate with a 30-degree double V weld. Once the specimen is done, click Accept. To display a drawing of your specimen on the sectorial scan, activate the overlay and select how many full skip you want to see. The specimen. For more information about how to create your specimen, please watch the 2 specimen creation video from this series. Creating channels at 45 degrees. Let's start by creating 2 phased array channels to inspect the top of the weld using focal laws at 45 degrees with a skew of 90 and 270 degrees. Every time a new channel is created, it will be a copy of the channel that was selected previously. We will do a linear at 45 degrees. To create your UT configuration, go in the Channels menu. By clicking on the current channel button, you can rename your channel. In this case, we are going to name our channel 45 degrees underscore left. Then select the configuration you want to create. In this case, we will select phased array pulse echo and select which probe and wedge will be used. You are now ready to start creating your focal laws. Click on the calculator. By default, your skew angle is 90 degrees. Multiple sweep types are available. Let's see each of them in more detail. The azimuthal sweep uses the full aperture to create each beam. As seen in the animation, the same set of elements create each focal law by applying different delays. This is represented by the red lines above the probe. A linear sweep uses an aperture that moves along the probe to create each beam. As seen in the animation, each set of elements creates one focal law and then moves by the selected resolution and creates another one, and so on, always applying the same delays. A compound sweep uses an aperture that moves along the probe to create each beam. As seen in the animation, each set of elements creates one focal law, then moves by the selected resolution to create another one, and so on, applying different delays to create each angle. In this case, we will select the linear sweep. Then, as seen previously, you have to select an angle for your inspection. For this example, we will use 45 degrees. We will also use an aperture of 16 elements scrolling from the first element to the last element of the probe. So we'll set the first element to 1 and the last element to 64 since the probe has 64 elements. The reverse probe could be used if the probe was set up upside down on the wedge so that the first element is at the top of the wedge instead of the bottom. As for the focal point, you have to choose between half path and true depth. Focal point types. True depth, same depth in the material for each focal law. Half path is the same distance along each focal law. For a linear channel, half path and true depth will result as the same specific depth inside the material for all focal laws. The difference will only be in the position. True depth will be the position inside the material, and half path will be the position inside the material along the angle. Using true depth makes it easier to set the position. We will set a depth of 88 millimeters, which brings us at the top of the plate. The position of the focal point is displayed on the left by a black dot and a black line. You can also set up your time base directly from the calculator, or set it to none in the calculator and set it up later in the UT settings. Let's set it up in the calculator. 3 options are available: half path, true depth, and distance. You can visualize your selection by looking at the red area of the display on the left. The selection of the time base will affect the display of your sectorial scan and the length of your A scan for each focal law to display only what's in the red area. Finally, position your probe on the plate by grabbing the wedge and moving it directly on the display. You want it to be looking at the top of the weld with this type of configuration. Once you are satisfied with the display on the left, click Accept. If we want to inspect both sides of the weld at the same time, we need to create a second channel. To do so, click on the Current Channel button and select New. Name your new channel. In this case, we will name the channel 45°_right. Creating a new channel, make sure you always copy the currently selected channel. All the parameters from channel 45° to the left have now been imported in 45° right. You can verify your parameters by opening the calculator. The only thing we have to modify to this channel are the skew angle and the probe connection. Change the skew angle to 270. You can see your probe moving on the display. Finally, change your probe connection according to your splitter cable. If you are using a Z-Tech splitter, the first connector uses connections 1 to 64, and the second connector uses connections 65 to 128. You want your probe connection in the calculator to be the connection on which your first element is connected. In this case, it's connection 65. To see your weld coverage with the 45° channels, tap the button on the right corner of the left display. Once you have made all the necessary modifications, click Accept. You can go back to the specimen menu and change the number of overlays to be displayed if needed. Creating channels at 60 degrees. Now, let's create two phased array channels to inspect the bottom of the weld using focal laws at 60 degrees with a skew of 90 and 270 degrees. Our next video will be on linear at 60 degrees. Before creating a new channel, select from which one you want to copy the parameters and make it your current channel. In this example, we will select the 45°_left. Then, to create your additional channel, click on the Current Channel button and New, and then give it a new name. In this case, we will name our channel 60°_left. You can now verify your parameters by opening the calculator. All we need to modify are the beam angle, the focal point position, and the time base. First, you have to select an angle for your inspection. For this example, we will use 60 degrees. As for the focal point, since we want to look at the bottom of the plate, we will select a depth of 44 mm. The position of the focal point is displayed on the left by a black dot and a black line. You also have to set up your time base so that it covers the bottom of the plate. We don't want to modify the position of the probe nor the probe connection, since we will be using the same probe for both the 45° and the 60° at the skew angle 90. Once you are satisfied with the display on the left, click Accept. To inspect both sides of the weld at the same time, we need to create a fourth channel. To do so, click on the Current Channel button and select New. Now, name your new channel. In this case, we will name the channel 60°_right. Creating a new channel, always make sure you copy the currently selected channel. So all the parameters from channel 60°_left have been imported in 60°_right. You can now verify your parameters by opening the calculator. The only thing we have left to modify to this channel is the skew angle and the probe connection. Change the skew angle to 270. You can see your probe moving along the display. Finally, change your probe connection up to 65. This parameter should be the same as channel 45°_right, since we'll be using the same probe for both channels at skew 270. To see your full weld coverage, tap the button at the right corner of the left display. Once you have made all the necessary modifications, click Accept. Our last video will be on views. Now that you have 4 channels, 2 on each side of the weld, let's display them all at the same time. Using the predefined layout, only 2 phased array channels can be displayed at the same time. Since we have too many phased array channels, we need to create our own layout. To do so, go in the Layout menu. In the Layout menu, multiple options are available. You can delete a view completely, empty the content from a selected view, and split a view. To display the 4 channels at the same time, we will delete the A scan and then split the V sectorial views in 2 horizontally using the split option. Then, to add content to a view, tap on the appropriate view and select the button showing one window. The View Properties page will open. In View Type, select the view you want to display. In this case, we'll select a sectorial weld. Then, in Current Channel, select the channel to be displayed. Repeat the same steps for the remaining empty pane. Here, we get 4 volume corrected sectorial scan, 2 for each side of the weld at 45 degrees and 60 degrees. For more information about the views and the custom layout, please refer to the view layout video of this series.